Hey everybody, Mr. Covey here. So this is the second part of 5.5, 5.5b. In 5.5a you talked about rhombi and squares. Today we're going to focus on kites, trapezoids, and isosceles trapezoids. And we're going to start here with kites. So a couple of important things about kites. They are usually attached to a string. If your kite's not attached to a string, it might fly away when you fly it. I'm just joking. Okay, side properties. So for a kite, you're going to have two pairs of consecutive sides are congruent. That means that the sides that are the same are next to each other. So those sides would be congruent, and these sides would be congruent. I'm going to skip down to diagonal properties. So your two diagonals in a kite are going to be perpendicular. And then for angle properties, we're going to have one pair of opposite angles are congruent. In this picture we're looking at here, the angles that are going to be congruent are D and B. Just those are congruent. A and C are not necessarily congruent. For other diagonal properties, one of the diagonals will bisect one pair of opposite angles. The way I usually remember this is if you look, B and D were the congruent angles. So the angles that are going to be bisected are the other two. So A will be bisected and C will be bisected. Finally, one diagonal will bisect the other. In this drawing here, it's going to be AC that bisects BD, meaning those two segments are congruent. Just one thing to note, this property and this property and this property are kind of half properties. They don't apply both ways. So it's one pair of opposite angles. It's not that opposite angles are always congruent. It's that one diagonal bisects one pair of opposite angles. Both diagonals don't bisect both opposite angles. Same with that last one. So that's just something to be careful about. Moving on to our trapezoid. By our definition, the only side property we have is one pair of opposite sides are parallel. As a result of this, consecutive angles are supplementary, and we need to be specific here. The way I think about it is upper and lower angles, as long as your trapezoid is drawn with the parallel lines being horizontal, are supplementary. So for instance, that angle and that angle are supplementary, and this angle and that angle are supplementary. And the reason for that is clear. Parallel, parallel, cut by a transversal. They are same side interior angles, and same with the other two. An isosceles trapezoid is a more specific type of trapezoid, meaning everything that holds true for a trapezoid also holds true for an isosceles trapezoid, but we add a few things. The legs are congruent. That is why it is called an isosceles trapezoid. Also, in terms of the angles, the lower base angles are congruent. And the upper base angles are congruent. Finally, the diagonals are congruent to each other. So as you might have guessed, we're going to use this to help us with algebra problems as well as proofs. One thing I want you to add that was left off is that side length CD is 2x. So let's go ahead and do this. It's an isosceles trapezoid. Our bases are CF and DE, meaning CD and EF must be congruent. It asks us to find EF. Well, looking at our diagram here, those two angles, D and C, must be supplementary, giving us that equation. Solve that. X is 16. Now that we know X, well, since CD and EF are the same, CD is going to be 2 times 16, so it's going to be 32, meaning EF has to be 32 as well. To find the measure of angle E, well, if X is 16, then angle D is 80 degrees, and since it's an isosceles, the two lower base angles must be congruent, so angle E has to be 80 degrees as well. Okay, let's look at a proof here. So it gives us that VRST is an isosceles trapezoid. The legs are VR and TS, and it wants us to prove that ARS is isosceles. So we're going to start by saying that we have an isosceles trapezoid that is given to us. Based on that, we know TS and VR, like we marked there, are congruent. Our reason is kind of similar to what we do for an isosceles isosceles triangle. We say if isosceles trap, then and we can just draw our picture. Those sides must be congruent. Or you can write if an isosceles trapezoid, then legs are congruent. Okay. Since an isosceles trapezoid, we also know that the lower base angles are going to be congruent. We need to use 3 letters to name those angles. So let's say angle VRS is congruent to angle TSR. And we can say if isosceles trap, then, and we can draw a little picture, those lower base angles must be congruent. Looking back at our picture now, we want to show ARS is isosceles. We can show that a few ways, but one way is to show that these two angles are congruent. And if you look at our picture, we actually have enough now to show these triangles congruent, since that side SR is a shared side. And once we get those congruent, we can use CP/CTC to say that angle 1 and angle 2 are congruent. Okay, so before we prove those triangles congruent, we need to say RS is congruent to RS by reflexive. And if you look back up at our picture, the shortcut we are using is side, angle, side. Okay, so come down here. Our triangles are VRS is congruent to triangle TSR. Again, we are using side, angle, side, and we're using steps 4, 3, and 2. And then by CP/CTC, angle 1 and angle 2 are going to be congruent. And now remember, we need to do this in 2 steps. We need to say 1 and 2 are congruent, therefore AR and AS are congruent, therefore isosceles. So make sure we do that in 2 steps. And then lastly, we get our conclusion, which is that ARS is isosceles, and our reason is just our definition. Okay, here's some always, sometimes, never practice. I'd like you to pause your video, do these 10 questions, unpause, and I will show you the answers. So take a couple minutes to do that now. Okay, take a look at those now. Check your answers, and if you have questions about that, they'd be good to ask in class tomorrow. Okay, I just have a couple more things I want to do. The first is identifying whether something is a parallelogram, rectangle, rhombus, square, or none of these, based on some given information here. I would highly recommend drawing a picture for each one of these. So for all of these, the quadrilateral is ABCD. So make sure you draw it with the vertices labeled in that order. This first one says AB is congruent to DC, and BC is congruent to AD. We have opposite sides congruent. The most specific quadrilateral we can identify it as is a parallelogram. Could it be a rectangle? Yes, but we don't know that the angles are congruent. Could it be a square? Yes, but we don't know that all the sides are congruent. Move down to number 12 here. Again, I draw a picture. I'll draw it down here. We have ABCD, AC, and BD bisect each other, meaning they cut each other in half, and they're perpendicular. If you look back at our properties, that describes a rhombus. That is the most specific quadrilateral you can say. For 13, we are given that AC and BD bisect each other and that they're congruent to each other. So if they bisect each other and they're congruent, it actually means that all of those are going to be the same. Looking at that, that means your shape is going to be a rectangle. It's as most specific as we can be. Okay, for 14, I'll draw it over here. It's very similar to 13. The only thing we're adding is that not only are they congruent and not only do they bisect each other, but they are also perpendicular. This will force ABCD to be a square. I want to leave 15 blank for now. You can ask your teacher about it in class. And I want to go down and do this last problem, 16 here. Okay, so this is what our picture should look like. ABCD is a rectangle, and the diagonals intersect at a point Q. And they tell us that AQB is 4 times BQC. So let's call BQC X. And then AQB is 4 times that, so this angle will be 4x. Based on that, we know that those two angles are supplementary looking at our picture. So we get that equation, and x is 36. But let's make sure we answer the question. They asked us to find the measure of angle QDC. So they want us to find the measure of that angle there. We can do a couple things here. First, we figured out x is 36, meaning angle DQC will be 144 since it's supplementary to that angle. And then we need to rely on our properties we know about rectangles. Specifically that the diagonals bisect each other, meaning DQ and QC are congruent, meaning triangle DQC is an isosceles triangle. Remember about isosceles triangles that these two bottom angles are going to be the same. So if you want a simple equation, call it y. 2y plus 144 has to equal 180. So you're going to get y is 18, meaning angle QDC is 18 degrees. And that concludes 5.5b.